Welcome back, everyone. Today we're diving into the visual system of one of the most fascinating creatures on the planet, the mantis shrimp.
Oh, absolutely. Their eyes are incredible.
I mean, we always hear about their powerful claws, right?
Right.
But their vision is just as remarkable, wouldn't you say?
Yeah, it's really something else.
So for years,
Right.
scientists thought they had the most complex vision in the animal kingdom.
Yeah.
But newer research suggests it might not be about complexity,
Yeah.
but about specialization.
Exactly. It's all about being perfectly adapted to their environment and their lifestyle, which is
Yeah,
a pretty unique one.
pretty intense.
Yeah.
Okay, so let's break it down.
Yeah.
What makes mantis shrimp vision so special? I mean, we humans, we have 3 color receptors, and we think we see color pretty well.
Mm-hmm.
But mantis shrimp,
They blow us out of the water.
they have somewhere between 12 and 16 different types of color receptors.
12 to 16, yeah.
What? That's mind-blowing.
It is. It is.
So what does that actually mean for what they can see?
Well, for starters, they can see a much broader spectrum of light than we can. They can see ultraviolet light. They can see far-red wavelengths.
So they're seeing colors that we can't even imagine.
Exactly. It's like a whole hidden world of color that's invisible to us. And it's not just about seeing more colors, it's about the detail they can pick up within those colors.
Okay, so more detail within the colors.
Yeah.
Can you give me an example?
Sure, think about a coral reef. All those vibrant colors, the intricate patterns, it's a visually complex environment. And mantis shrimp can use their incredible color vision to distinguish between different types of coral, to spot prey that's camouflaged against the background, to navigate their way through this complex 3D world.
So it's like they're seeing a high-definition, super-saturated version of the reef.
You could say that, yeah.
But wait a minute, all those extra photoreceptors, all those colors they're seeing, wouldn't that be incredibly demanding on their brains? Like, wouldn't their brains just be overloaded with visual information?
It's a good question, and you'd think so, right? But they have a clever way of handling all that information. It's called interval decoding.
Okay, interval decoding. Break that down for me.
So instead of trying to analyze every single wavelength of light they see, they basically group them into categories. Think of it like this. Imagine trying to identify a color by listening to different tuning forks.
Okay, I'm following.
The one that resonates the strongest, that's the color you're seeing. It's a simplified system, it's fast, and it's efficient.
Okay, I get it. But wouldn't that make their color perception less accurate?
To a certain extent, yes. Their color discrimination isn't as nuanced as ours. They might not be able to tell the difference between 100 shades of blue, for example.
Right.
But remember, they're not trying to paint a masterpiece. They're trying to survive. And for that, speed and efficiency are key.
Okay, that makes sense. So they've traded some color subtlety for speed and efficiency.
Exactly.
But there's more to the story, right? Because they also have this amazing ability that we humans can only dream of: polarization vision.
Oh, absolutely. That's one of the things that makes them truly unique in the animal kingdom.
Okay, so what is polarization vision? I mean, I've heard the term, but it's always sounded a bit like science fiction to me.
Well, it's not fiction. It's a very real ability. And it allows them to see a whole dimension of light that's completely invisible to us. You see, light waves can vibrate in different directions, and that's polarization.
Okay.
We humans, we can't detect those different vibrations. But mantis shrimp can, and it opens up a whole new world of visual information for them.
Like what kind of information?
Well, for starters, it helps them navigate. They can see patterns of polarized light in the sky and in the water that we can't even perceive.
Wow, so they have their own built-in GPS.
You could say that. It also helps them find prey, especially prey that's camouflaged. You see, some animals have evolved to reflect polarized light in a way that makes them blend in with their surroundings.
Okay.
But mantis shrimp can see right through that camouflage because they can see the polarization patterns.
So it's like having X-ray vision for underwater camouflage?
Kind of, yeah. And here's another cool thing. They use polarization to communicate with each other.
They can talk to each other with light.
In a way, yes. They can change the polarization of the light they reflect off their bodies, creating flashing signals that are invisible to most other creatures.
So they have their own secret language of light? That's amazing.
It really is. And one species of mantis shrimp, Gonodactylus smithii, they have the most optimal polarization vision in the entire animal kingdom.
So they're like the polarization champions of the world.
Exactly. They can see all the polarization components, linear and circular, simultaneously.
Wow, that's incredible.
Yeah.
I'm starting to see why scientists thought they had the most complex visual system for so long.
Yeah, it's pretty remarkable. But it's not just about complexity, it's about specialization. And that's what makes them so fascinating.
So how does this polarization vision actually help them in their daily lives? I mean, we've talked about navigation, prey detection, communication,
Hmm.
but what else?
Well, think about their environment. They live in a world where light behaves very differently than it does in air. Light gets scattered and absorbed in water, so it can be very difficult to see clearly. But polarized light can penetrate further through murky water and it's less affected by scattering. So for a mantis shrimp, being able to see polarized light is like having a superpower that allows them to see through the visual clutter.
That's like having a built-in filter that cuts through the noise and reveals the hidden patterns and signals.
Exactly, and that's crucial for their survival.
Okay, so we've got superpowered color vision, we've got polarization vision. What else makes their vision so special? I'm ready for more mind-blowing facts.
Okay, brace yourself, because they also have something called trinocular vision.
Trinocular vision? What's that?
It basically means they can see in 3D with just one eye.
Wait, how's that even possible? I thought you needed two eyes to see in 3D.
You do in most cases. But mantis shrimp, they have a unique arrangement of ommatidia in their compound eyes.
Remind me what ommatidia are again.
They're the individual units that make up their compound eyes, like
Yeah.
tiny little lenses.
Right. Okay.
So in mantis shrimp, multiple ommatidia focus on the same point in space, and this gives them depth perception in a single eye. It's like having 3 viewpoints in one eye.
So with two eyes, they're essentially seeing the world from 6 different viewpoints simultaneously.
You got it.
That's incredible. No wonder they're such efficient hunters. But you mentioned that their vision is specialized, not necessarily complex.
Mm-hmm.
So how does this trinocular vision fit into that?
Well, it's all about how their eyes are structured. They're divided into 3 distinct regions, each specialized for a different visual task.
Okay, let's unpack that.
Well,
What are these 3 regions and what do they do?
you have the upper and lower hemispheres, which are primarily responsible for detecting movement and recognizing shapes.
Makes sense.
Then there's the midband, and that's where the magic of color and polarization vision really happens.
Okay, so it's like a highly specialized visual processing center right there in the middle of their eye.
Exactly. Rows 1 through 4 of the midband are packed with those color-sensitive photoreceptors, while rows 5 and 6 are dedicated to detecting polarized light. It's a remarkable example of how evolution can optimize a system for specific tasks.
So it's like they have a whole team of specialists working together in each eye.
Yeah, a real visual dream team.
Okay, so we've covered a lot of ground here.
Yeah.
We've talked about their incredible color vision, their polarization vision, their trinocular vision. But what's the takeaway here? What does it all mean?
It means that mantis shrimp vision is a marvel of specialization. It's not just about seeing more, it's about seeing better. It's about extracting the most important information from their environment and using it to survive and thrive.
And it's a reminder that there's more than one way to see the world.
Absolutely.
Our human vision is amazing in its own right, but the mantis shrimp's visual system is a testament to the incredible diversity and ingenuity of nature.
It really is. It makes you wonder what other amazing adaptations are out there just waiting for us to discover. And it really highlights how the mantis shrimp's visual system isn't just about seeing more, it's about seeing what's important for their survival.
So it's not just about quantity, it's about quality. Like, they've traded some of the nuances of color vision that we humans enjoy for the ability to see polarized light and process visual information at lightning speed.
Precisely. It's a fascinating example of how evolution doesn't necessarily favor complexity, but rather the most efficient and effective solution for a given environment and lifestyle. Remember, they live in a fast-paced, visually complex world where split-second decisions can mean the difference between a meal and becoming one.
Okay, I'm starting to get the picture. Their vision is a highly specialized tool, perfectly honed for their unique challenges. But, we humans are pretty proud of our visual abilities too. How does their vision stack up against our own receptor? I mean, sure, we only have 3 color receptors, but we can appreciate subtle shades of color that a mantis shrimp probably wouldn't even notice.
That's true. You humans are masters of nuance when it comes to color. You can appreciate the subtle differences between a crimson sunset and a blush pink rose. But remember, those abilities come at a cost. Your visual system is much more complex and requires a lot more processing power.
So we're trading speed for subtlety, kind of like the difference between a race car and a luxury sedan.
That's a great analogy. The mantis shrimp's visual system is like a high-performance race car built for speed and efficiency. It sacrifices some detail and nuance for lightning-fast reactions. Your human visual system, on the other hand, is more like a luxury sedan, designed for comfort and a smooth, detailed ride.
But hold on, wouldn't a more complex system like ours be inherently better, more information, more detail, that should be an advantage, right?
Not necessarily.
Hmm.
Remember, evolution is all about adaptation. The mantis shrimp's visual system is perfectly adapted to their needs. They need to be able to quickly identify prey, assess threats, and navigate their environment, often in murky or dimly lit water. Their vision is their key to survival.
So it's not about having the most advanced system, but the most appropriate system for the task at hand. And for the mantis shrimp, that means sacrificing some color resolution for the ability to see polarized light and process visual information with incredible speed.
Precisely. It's a fascinating example of how different evolutionary paths can lead to very different but equally effective solutions to the same basic problem: how to see.
This is making me think about how our human vision has been shaped by our own evolutionary history. I mean, we're not hunting prey on a coral reef, so our visual system has developed very differently.
Absolutely. Your human visual system is optimized for your needs, like recognizing faces, reading, and navigating complex social situations. And don't forget about your depth perception. Your two eyes working together create a very precise 3D image of the world.
That's true. Our binocular vision is pretty amazing. But, I can't help but be a little envious of the mantis shrimp's ability to see polarized light. It's like they have a secret window into a world that's completely hidden from us. I imagine their world must be so much more vibrant and dynamic than ours.
It's certainly a different way of experiencing the world, and it highlights the fact that there's no one right way to see. What's optimal for one species might be completely useless for another.
Speaking of different ways of seeing, I'm curious about the evolutionary history of the mantis shrimp's visual system. How did these incredible eyes come to be?
Well, mantis shrimp have been around for a very long time, over 400 million years. Their lineage branched off from other crustaceans way back then, and their visual system has been evolving ever since. It's likely that their complex eyes developed gradually over millions of years, driven by the need to hunt effectively and survive in their visually rich and dynamic underwater world.
So it's a story of adaptation and refinement over countless generations, each tiny improvement in their visual system giving them an edge in the struggle for survival.
Exactly, and it's a story that's still being written. Scientists are constantly making new discoveries about mantis shrimp vision, which challenges our understanding of how vision works and what's even possible. For instance, remember when we talked about how their brains weren't overloaded with visual information because of interval decoding? Well, it turns out there's another layer to that story. Their eyes actually pre-process visual information before it even reaches the brain.
Hold on, you're telling me they have some kind of built-in image processing happening right in their eyeballs. How does that work?
It's truly remarkable. They essentially have a pre-processing system built right into their eyes, reducing the workload on their brain and allowing them to react even faster. Think of it like this. Instead of sending all the raw visual data to the brain for processing, the mantis shrimp's eyes actually extract the most important information first. They do this by comparing the signals from different photoreceptors, identifying patterns and contrasts, and essentially summarizing the visual scene before passing it on to the brain.
That's incredible. So their eyes are doing some of the heavy lifting, freeing up their brains to focus on making quick decisions and coordinating those lightning-fast strikes. It's like having a supercomputer built into their eyeballs.
Precisely. It's a brilliant example of how evolution can optimize a system for maximum efficiency. And remember, we're still just scratching the surface of understanding how this complex visual processing system works. There are likely many more secrets waiting to be discovered.
It's mind-boggling to think about all the hidden complexity in such a seemingly simple creature.
Hmm.
But this deep dive isn't just about understanding the mantis shrimp for its own sake, right? There must be some broader implications for us humans.
You're absolutely right. The mantis shrimp's visual system isn't just a biological curiosity, it's a source of inspiration for scientists and engineers. By studying their unique adaptations, we can learn valuable lessons about how to improve our own technologies and potentially even develop new ones.
So it's not just about understanding the natural world, but also about applying that knowledge to solve real-world problems. Tell me more about how the mantis shrimp is inspiring innovation.
Well, for example, researchers have developed a camera that mimics the mantis shrimp's polarization vision to detect cancerous cells. It turns out that cancer cells often reflect polarized light differently than healthy tissue, so this camera can potentially spot cancer earlier and more accurately than traditional methods.
That's amazing. So we could be using mantis shrimp vision to fight cancer.
It's definitely a promising area of research, and it's not just cancer detection.
Oh, there's more.
Yeah, their ability to see such a wide spectrum of light, especially in the UV range, is inspiring new developments in imaging technology, like hyperspectral cameras.
Hyperspectral cameras.
They can capture a much broader range of wavelengths than traditional cameras, kind of like seeing a rainbow of colors that are invisible to us.
So we're talking about seeing things we never even knew existed.
Exactly. And these cameras have applications in so many fields, from environmental monitoring to agriculture, even art restoration.
Wow, the mantis shrimp is a real gift that keeps on giving.
It really is. It makes you wonder what other amazing adaptations are out there in the animal kingdom, just waiting for us to uncover them.
Right. I mean, we're constantly learning new things about the natural world.
Absolutely. And the more we learn, the more we realize how much we still don't know.
It's humbling, isn't it?
It is. It's a reminder that we're just a small part of this incredible web of life.
Well, I think it's safe to say that the mantis shrimp has earned its place as one of the most visually impressive creatures on the planet.
I completely agree. It's not just about the number of photoreceptors they have, it's about how they use them. It's about the specialized systems they've evolved to make sense of their world.
Right, it's not just about seeing more, it's about seeing better. It's about being perfectly adapted to their environment.
Precisely. And I think there's a lesson there for us, too. We can learn a lot from nature's ingenuity, from the way evolution has solved problems in creative and unexpected ways.
Absolutely. So the next time you see a mantis shrimp, maybe at an aquarium or in a nature documentary, take a moment to really appreciate their incredible vision.
Imagine the world they see. A world full of vibrant colors, hidden patterns, and a depth of visual information that we can only dream of.
It's a reminder that there's so much more to the world than what we can see with our own eyes.
And who knows what other secrets are out there, just waiting to be discovered.
That's the beauty of science, right? There's always something new to explore.
Always. And that's what makes it so exciting.
Well, on that note, I think we'll wrap up this deep dive into the amazing world of mantis shrimp vision.
Thanks for having me. It's been a pleasure.
It's been a fascinating conversation. And to our listeners, thanks for joining us. Keep exploring, keep learning, and we'll see you next time for another deep dive.